right, good morning. How's it going? We got video 6.2, part 2 on solving exponential equations inequalities via word problems. Recall that the equation for an exponential function looks like this. Y equals a times b raised to the x. B is our base, and a is the initial value. So number 1 says Christian starts an experiment with 7,500 bacteria cell. Whatever they're starting with, that's your A value. After 4 hours, that's kind of like your X variable. That's your time. There are 23,000 cells. So kind of like an ordered pair, we have the ordered pair of 4, 23,000. With the starting value of 7,500. So writing an exponential function to model, we have kind of like our x and our y values, and we have an a value that it starts with. We don't have the b value, so we have to solve for b. To do that, we're going to plug in everything we know, the 23,000, the 7,500 for a. We don't know b, but we know x is 4. Going ahead and trying to solve this, we're going to divide both sides by 7,500. Doing that, typing it into my calculator, I get about 3.06. Repeating. Equals now, after those cancel, b raised to the 4th power. And to cancel out the 4th power, we do the 4th root. And the 4th root of 3.06 repeating. Let me go and type that into my calculator as well. We get... 1 second. .06. I get b value to be 1.323, approximately rounding. So our function looks like y equals, we're still going to write the a value of 7,500. Now we have a b value. I'm going to separate it with parentheses of 1.323, and we're just going to leave x as x. Always leave it as the x and the y. No numbers to put in there. Just analyzing this, it looks like a growth because my b value is greater than 1. Now the next question says how many bacteria cells can be expected after 12 hours. So remember, time is the x. So we're going to plug in 12 in for x. Writing that here, it's going to look like this. And all you have to do is type that expression into your calculator. And I get the number of bacteria to be 215,664. And I could round it up to 665, and that would be it. I'll even label it and say bacteria. Okay, that's writing an exponential function given a word problem. Remember, you need your A and your B. Sometimes you'll have to find your B if you're given an ordered pair. Now, another type of exponential word problem we can face is a compound interest word problem. Here we have plenty more variables that you need to know. We have P, which stands for the principal amount invested. The principal is how much it starts with, kind of like the 7,500 we just did. N is the number of compoundings per year. Now the n could be annually, which is 1. Let me go ahead and write this down for you. Annual would be 1. Semi-annual would be 2. We can do quarterly, which is 4. We can do weekly, which would be 52 weeks in a year. We could do daily, which would be 365. We could do monthly, which would be 12. Now, T is time in years. Be careful about that. And then R is the interest rate, and make sure you put that as a decimal. A also stands for the amount in the account. So now solving this problem, we have an investment account that pays 4.2%. That's your R. Compounded monthly, so I'm thinking that the N value is going to be 12. If 2,500 is invested, that's your principal. What's the balance after T years, or 15 years? That's going to be my T. Let's plug in everything that we know. We don't know the amount. We know the principal is 2,500. And then we have 1 plus, and R is our rate, which is 0.042, divided by how many times it's compounded. We have 12. And then we're going to raise that to the power of n times t, which is 12 times 15. Going ahead and typing that into my calculator. Be careful with your parentheses. And I get the amount to be at the end, 4,688. And since we're talking about money, I'm going to round to 2 decimal places, 87 cents. And that's the balance after 15 years. Just a couple reminders. Don't forget R is a decimal. Move it over 2 times to the left. Don't forget T is in years. I can trick you by maybe putting months. P is the principal, how much it starts with. And then N, which a lot of people get a little confused about, is the number of times it's compounded. In this case, it was monthly, so N was 12. Let me know what questions you have on these word problems. We'll do more practice in class. Have a great night.